easily deploy computers and stuff into Linux writing only in Python. So all the C, sites, all that stuff is Python. We use Docker as well to deploy. But yeah, I mean, Python 3B+.
Okay, so I think we're gonna get started. So this is Steve from Vector Zero. I was kind of particularly excited for this because Steve is a serial entrepreneur. I think he can probably get into that later, but two of the companies that he found, my understanding is like the first one became Rockstar San Diego.
Yeah, I didn't actually found that company, but I can do a little
Sure.
through that.
And then the second one was acquired through Sear Technology, which dominates the map industry for automotive, and he's working on the third company for simulation, like maps for like autonomous cars and things like that. So I'll let him take over from here.
So should I stand or maybe she can sit a little bit if that's all right?
Whatever makes you comfortable.
Everyone else is sitting. So yeah, I was going to show a little bit about what we do up at Vector Zero. So we're up in Carlsbad, and I'll just give kind of view of the company here. But we make, so we work in the autonomous vehicle business in simulation of autonomous vehicles for testing, and mainly self-driving cars is what I mean by autonomous vehicle, but it could be broadened to other robotics, other applications. The autonomous vehicle space obviously very hot right now. A lot of people pouring money into it. So there's several startups in the simulation space. There's several companies focusing. The big car companies working on this have all come to the conclusion that it's going to require thousands and thousands of hours of simulation to test and develop these autonomous vehicles. Even once they're working, even when they're functioning, they still want to rerun the same tests over and over to make sure that they didn't break anything. Every time they're tweaking the algorithms, they want to be able to rerun the same tests and verify that everything worked. So everyone in that field has come to the conclusion that simulation is going to play a huge role in this. And the makers of autonomous vehicles, some of the folks we talk about setting up clouds of tens of thousands of CPUs that are just running 24 hours a day and rerunning the same tests over and over and over again, and running various little simulations. So several companies in the last few years have started up to really address this matter. We're one of them, but we've taken a pretty unique approach from these other companies. Instead of really focusing on the simulation side, we focused on the modeling side, the preparation of the environments. And turns out that that's something that no one else has really put a lot of emphasis in. And so we've kind of become, in just the year and a half since we released our software, we've become kind of the standard product that everyone is now using to build roads, to build the actual road environment. So we make a piece of software that allows you to interactively build scenes like these and set them up for simulation. So we started the company in February 2017, so it's not even 3 years old. We have 14 employees currently. We're in Carlsbad. We have actually now over 60 customers, so I got to update the slide, in the autonomous space, and that includes 12 or 13 of the major automakers like Ford, General Motors, and Daimler, and Toyota, and Honda, all these big companies. Includes several big hardware companies like NVIDIA and Samsung and Intel, all customers. There's also over 50 universities now using our software. And incidentally, I teach at UCSD as a lecturer, as a guest lecturer. I teach computer animation programming, and I teach a physics simulation class there too. But these pictures show some of the output of our software, and in fact, you can build a scene like this in a couple of hours, probably. Something like this might take 3-4 hours for somebody who knows what they're doing. So our main product is called Roadrunner. It's an interactive tool that you can fire up and run and click with the mouse and build 3D scenes. So it's an interactive tool for rapid road modeling and creation of the environment. It's got a very intuitive user interface, sort of designed for ease of use, pretty powerful in terms of editing, runs on Windows and Linux. We find that more than half of our customers, I think, use Linux at this point. A lot of the automotive companies are big Linux users. And the tool itself is evolving a lot, and there is a free demo version available if anyone wants to check it out. The professional version is a little more expensive, but we can arrange things for, you know, if you're doing experiments or research. So it's based on we have internally a road model representation that allows us to represent very complex situations. It's kind of designed from the start to handle very complex road networks, because we know that a simple 90-degree intersection in four-way is going to get old quick, and so we designed it with these kind of worst case scenarios in mind. This is an actual real location. This is 1, 2, 3, 4, 5 little roundabouts arranged in one giant roundabout. This is actually in Swindon, England. This is believe it or not, it's actually a real place. And there's another one similar to this in England somewhere. I don't know why they do it. I think they're just showing off. It's not even a very big town. I don't know why they need an intersection that complex there, but it's pretty famous. But anyway, we can not only build a 3D textured model for rendering, but the model we build has all the semantic information about where roads are and where lanes are and where stopping points are, and so it's actually a simulation-ready model. So let me quickly show a video that shows some of our editing stuff, kind of give a live view of it here. I might skip over some of this, but I'll talk over some of it. But so this shows, again, just it's an interactive tool designed very much click with the mouse. There's a road editing mode where we lay out the main shape of the road. We can then go in and add individual lanes. Lane markings can be added, and lane markings can all be customized, so you can create little assets for lane marking types and customize the dash spacing or the size, the color of the markings, etc. So everything is set up to do international roads, so it's nothing US specific, so you can create your own library of road marking styles. So you see here adding turning lanes, carving in different lanes. We can change the markings on any span independently. This is called a slip lane here, a turning lane. I got some tools for adjusting corners. The video doesn't show much in the way of roundabouts, but shows some basic roundabout-like capabilities. The whole road is completely editable, so you can add these width markers at any point and make adjustments as fine scale or as coarse scale as you want. This one shows here that lane widths. As you adjust this one maintains the same width if you want, or you can set this one to not add it on the width, so just different controls over that. We have control over the cross section of the road, so you can control banking and crossfall and the shape of the road. This system is actually going to undergo some improvements, but you can set these key points along the road and adjust the cross section or try to blend between them. So you have control over all the curvature underlying the road. Real roads have a lot of very specific curvature requirements in how they're designed. We control the vertical heights of the roads as well, and the vertical shape of the road is based on we use the same types of curves and the same types of engineering principles that real roads are designed with. Obviously, no one's going to build a real road like this, but
new roads.
Right. But the types of curves that we use are all based on actual road curves. So the horizontal, the top-down view is designed independent of the vertical profile of the road. This is showing some of the bridge capabilities. This is actually, we're doing some improvements here, so we have more control over intersections on bridges, and we don't have good control of that right now. We're adding tunnels and better bridge control. posts, things like this can be brought in and customized and adjusted. And this shows the level of control over road markings. So we have different types of marking, crosswalks. Again, these are all based on styles, so you can create your own library of crosswalk styles and adjust the dash sizes, the colors, etc. Is that me? Getting down into the finer scale. And then these are a bunch of these are stencils we can place on the road. And these are just SVG files. They could be image files. They could be bitmaps as well. It's actually not too hard to find the proper SVG shapes for all these. Like the U.S. Department of Transportation will publish files that have all that. You saw a second ago control over materials, so we can make the paint look faded. So if people want to use this to test computer vision algorithms, they sometimes want to verify that the car will drive on, if the paint is all chipped up. We can add things like dirt and cracks and more visual features if desired. Some of the, I think a fairly small number of our customers really care about high quality visuals. Most of the customers use the software for creating road networks for path planning simulation, not so much for perception simulation, if that makes sense. I can get into that detail more if you're interested. So a lot of our customers, they care about having a road network with the lanes set up and the geometry set up. They tend to be, at least currently, less concerned about these finer scale visual features because, like I said, less people are doing perception simulation with it. But this shows how we can control all these other layered things on the road, and we can control what's drawing on top of what. So pretty detailed control of markings and stuff. The prop system allows us to bring in files, 3D files from other 3D modeling tools. If you're familiar with tools like Blender and Maya, we can import any 3D shape from there and just place it as what we call a prop. So a prop is just any external file, so trees and buildings and such. And we also offer a library of several hundred standard kind of prop tools, or props themselves. And this shows some of the ability to place things along curves and add some randomization, different rules for placing things. You can place props on curves, you can draw a polygon and fill in an area.
Throw in a cow here and there.
You can put in, like we were building a large scene for, one of our customers had this big test environment that they built. We were making a newer version of it, and we were looking through it, and they had like UFOs hiding in they had like the Loch Ness Monster somewhere, little things like that. So showing, we can make random prop distributions, so we can say that here's a set of different trees, and it's going to be 1/3 this type and 50% that type, and be able to control the portions.
Anything for weather, like snow or?
We don't focus on that. Typically snow and things like that are added in the simulator after, so we generally focus on building the static environment. Mm-hmm. As we get more into the simulation side as well, I could see us adding more capabilities like that. So yeah, typically the output of our tool is a static model that would then be brought into something like Unity or Unreal. And then you could add all kinds of other dynamic effects like wind and weather and snow and rain and stuff.
So speaking of outputs, is there a standardized method or?
Yeah, there is a road map format that's pretty standard called OpenDrive. It's, I would say 75% of our customers use it. It's one of those standards that it's a tough standard to work with, and we have probably the best tool for editing that standard. So anyone who's even trying to use that standard is now using our software because it's such a tricky standard. But it's also under active development, and but by active I mean very slow.
Dynamically changing.
Yeah, but more meetings than actual changes. But a lot of companies are involved in it, so it's kind of a slow moving process. but also we output 3D geometry to various standard 3D formats like FBX, and you know, we can directly output the 3D geometry into something like Maya or Blender, typically through FBX is the most common. And then this shows the sign editor, so this is all in the tool as well. You can type in strings and add fonts and add graphics. This also is very international, so it can do, you know, Chinese characters and Japanese. It's all Unicode, so whatever you want to put in there. I think this shows ahead a little bit, but shows that you can cut and paste in Unicode strings. This shows the traffic signal system. So we have our own library of signals, but you can add your own and add different signal types. And we can configure it so that every single bulb can be individually set. And this is just from another file, so you can create a texture that has your different bulb types. But you can set individual bulbs on the signal to any type you want. You can then very quickly snap together these assemblies, we call them. Objects are built to be attached together, so they can have these curves inside them that are attachment curves, so things snap real quick. So you can build, you know, a custom set of signals very quickly. Then we have a tool for signalizing, which controls all the phasing and says that, okay, you know, these guys now have a left turn, now these guys get to go straight, etc. And that's completely editable. Everything in the tool is very editable. So you can always go in and set any individual pathway to be whatever you want, but it also has some nice higher level tools for just give me a standard left turn, protected left turn, or permitted left turn. You see it automatically configures all the bulbs if everything is set up correctly. And so now I'm scrolling through and I show that, well, these left turns are kind of close to each other, so we're going to split this phasing out, and we're going to have a separate phase where these guys get a green light, and then a separate phase where these guys get a green light. So that shows the ability to build a custom set of phasing for the intersection. And again, all the bulbs automatically configure. And this shows just actually running a traffic simulation on it. So we do some simulation work here, but that's not really a part of our product yet. The product that ships is just the static environment modeler. And we're working on tools for doing traffic simulation and scenario simulation as well, but in the meantime we're compatible with a lot of other tools out there that do this side of things. So yeah, that's a quick overview of the feature set. So I'll go on through a couple more slides. One of the things that video doesn't show is there's a lot of mapping companies out there. Here Maps is one of them that drives vehicles around. They have a fleet of 50 or 100 or more than that cars all around the world, and they drive around. We drive the same roads over and over with GPS and with cameras and with LiDAR and all that. And they extract these detailed maps, kind of like the red and blue green strips you see under here, that have these detailed lane boundary information, very geometrically accurate, that has road heights and road geometry, and is within, you know, a few centimeters of the real world, and depending on how accurate their GPS happened to be when they were driving it. But they produce these semantic maps of just the road information. We can import that and turn it into more of a 3D map. So we can bring in these kind of simplistic ribbons and turn them into actual roads, and then either manually or automatically add signs and add signals. It depends on what's in the map data. So some of these mapping companies actually will map out every single signal and will tell us, you know, we'll be able to just get a file that says, you know, where every bulb is. But typically they won't have things like, they won't tell you where the trees are, they won't tell you where the posts are holding up those signals, so we'll just get these kind of floating signals in the air. So that's what we find is there's some great map data out there that may have very accurate road information, but it's not going to have everything. So when we actually go to build a real location, we often have to bring in lots of different data sources. So we might bring in one of these HD high definition maps from Here Maps, but then we might also bring in an aerial image that was taken from, you know, an airplane, or we might bring in ground level LiDAR or other types of data for that area to help us as visual reference to then build on top of it. workflow. These are just some pictures that show some of the data out there. These are several different companies that we work with that collect map data. So this is kind of the data you might get. These lines are very accurately positioned, but they're just lines, right? You can't really drive a 3D simulation on that, so we have to bring this in and turn it into actual roads. But these are, again, some of the partners we work with on that.